Good day, everyone. Today we shall be looking at further math, May June 2023, paper 1, area 3. So the first question is mathematical induction. Now prove by mathematical induction for all positive integer n, 5 raised to the power 3n plus 32 raised to the power n minus 33 is divisible by 31. Now the first thing that should come to your mind is by assuming n to be 1. And let's see what it's all about. Okay, just assume the first thing in mathematical induction is we always assume n to be 1. I'm going to represent this function as p raised to the power n. So we have not p raised to the power n, p. I'm going to this function as pn like this. Since pn is 5 raised to the power 3n plus 32 raised to the power n minus 33, right? So p1 with 5 raised to the power 3 times 1, 3, 32 raised to the power 1, 32 minus 33. So 5, so p1 will be 5 raised to the power 3 is 125 plus 32 minus 33. 32 minus 33 is minus 1. 125 minus 1, so P1 is 124. So since and 124, is it divisible by 31? Let's confirm it. So let's divide 124 by 31. It gives us 4. Yes, which means for n equal to 1, P of P1 is 2, that is divisible by 31. Okay. Now, if for n equal to 1 is divisible by 31, which means that for n equal to k, if n is equal to k, pk will be 5 raised to the power 3k plus 32 raised to the power k minus 33 is also divisible. It's also divisible by 31. If n equal to 1 is divisible by 31, so instead of putting 1, I put it as k, an alphabet should also be divisible by 31. So the next step is you now put n. The next step is to put n to be k plus 1. So we write pk plus 1 will be 5 raised to the power 3n. N is now k plus 1, close the bracket, plus 32 raised to the power n, which is k plus 1, minus 33. Apply the law of indices. So pk plus 1, okay, open the bracket for 3k plus 3 plus 32 raised to the power k plus 1 minus 33. So when you apply the law of indices, pk plus 1 is the same thing as 5 raised to the power 3k multiplied by 5 raised to the power 3 plus 32 raised to the power k times 32 raised to the power 1 minus 33. So pk plus 1 will be 5 raised to the power 3 is 125. 125, 5 raised to the power 3k plus 32 raised to the power k minus 33. After doing this, the next step is to find pk plus 1 minus pk. Pk plus 1 minus pk will be, what's pk plus 1? 125. 5 is the power 3k plus 32 is the power k minus 33 minus pk. Pk is 5 is the power 3k plus 32 is the power k minus 33. So pk plus 1 minus pk will be, 125 times 5 is the power 3k plus 32 times 32 is the power k minus 33. Open the bracket like minus 5 is the power 3k minus 32 is the power k plus 33. So minus 33 cancel plus 33, that's out. So therefore pk plus 1 will now be 125 times 5 is the power 3k plus 32 times 32 is the power k minus 5 is the power 3k minus 32 is the power k plus pk. I transfer this pk to the other side. Hence, pk plus 1 will be, now let's collect the like extent. This 5 is per 3k, 5 is per 3k. Bring it out. What do you have? 125 plus 1. Is it plus 1 or minus 1? I think it's minus 1. This 32 is per k, 32 is per k. When you bring it out, 32 is to the power k. What left here? 32 minus 1 plus pk. And previously, we've proved that pk is divisible by 31. So hence, let's conclude. Hence, so pk plus 1 will be, now 125 minus 1, that's 124. So 124. So pk plus 1 will be 124 times 5 is the power 3k. The next term will be 32 is the power k. Yeah, 32 minus 1 is 31. Okay. Times 31 plus pk. Now, since this side is divided by 31, this side too is also divided by 31, and earlier we've proven that pk is also divisible by 31. Hence, pk plus 1 is true, that is, it's divisible by 31 for all integer. So we can now conclude that by mathematical deduction for all integer of n, that the function is divisible by 31. That's it. The next question. Now, this question is under summation. Now, the question is, use standard result of formula from MF19 to show that this equals to this, where A and B and C can be determined. Okay, it's quite straightforward. Now, this summation can also be written as is summation R from R to 1 to n 6r squared, take it individually, plus summation from r to 1 to n 6r minus summation from r equal to 1 to n 5. So which can also be written as which is the same thing as bring the constant r 6 from r to 1 to n summation r squared, bring the constant r 6 summation from 1 to n, this is r minus, okay, if you bring the constant 5 out from 1 to n, what will be here is 1. Now the question asks us to use the MF19, that's the standard result formula. So what do you have from here? When you check your MF19, the standard result formula, summation r squared is the same thing as 1 over 6 n plus 1 2n plus 1 plus the next one is 6. From the standard result formula, what is summation r? Summation r will be half n bracket n plus 1. That's summation r, half n bracket n plus 1 minus 5 summation 1 from 1 to n, which means only occur once, from 1 to n. This summation 1, that will give us n. So from here, 6 cancel 6, 3 here 1, 3 here 2 here 3. So what do you have here? We have n into bracket n plus 1, 2n plus 1, plus 3n into bracket n plus 1 minus 5n. It look as if n is common. So when you bring n out, what left is n plus 1, 2n plus 1 here, which could expand. You can expand it and get 2n squared plus n plus 2n plus 1. What left there is 3, 3n plus 3, and what left there is 5. So which could be 2n squared plus 3n plus 1 plus 3n plus 3 minus 5. Let's arrange properly. Now here we have 2n squared, 2n squared plus 6n, 1 plus 3 is 4, 4 minus 5, 4 minus 5 is minus 1. So open the bracket, then we have 2n cubed plus 6n squared minus n. Remember the question asks us that it should be in this form, an cubed plus bn squared plus cn. So in this form, which means the value of a will be 2, while b is 6, and c is minus 1. That's the answer for this. Now question B, use method of differences to find summation 6r squared plus 6r over r squared plus 1 in terms of n. Okay, now to do that, you have to use method of differences. To do that, you're going to resolve this function, partial fraction. Now there is a clause there. The degree of the numerator is 2. The degree of the numerator is also 2. Once you see such clause, the first step is to divide by polynomial, because the degree of the numerator and denominator are the same, which is improper. So let's divide by polynomial to correct that default. 6r squared plus 6r minus 5 divided by r squared plus r. 6r squared divided by r squared, that's 6. 6 times r squared, 6r squared plus 6r. What remains? This cancel this. What remains there is 5. 5 cannot go in r squared, so which means that 6r squared plus 6r minus 5 over r squared plus r is the same thing as the quotient, and sorry, what we have left is 6 minus 5 over r squared plus 1, r squared plus r. Now, after doing this, now this is equivalent to this. So before we move further, we need to also break this down. 5 over r plus 1. We need to break it down into partial fraction. So to break it down in partial fraction to be equal to a over r plus b over r plus 1. So into partial fraction, at the end of the day, we're going to have 5 equal a bracket r plus 1 plus br. That's into partial fraction. So the first step, in partial fraction, we put r plus 1 to be 0. So therefore 5 will be r plus 1 is 0. At that point, b is minus 1. So from here, our b will be minus 5. The next one is to expand. 5 equal ar plus a plus br. Substitute what you're supposed to substitute there. 5 equal, collect the likes then, ar and ar, which means r into bracket a plus b plus a. So look for the coefficient. On the left hand side, there's no coefficient of r. Since there's no coefficient of r on the left hand side, which means a plus b will be equal to 0. Then a equal to minus b. And what was our b earlier? Our b is minus 5. That will be minus 5. A is 5. So since our a is 5, so therefore we can say that summation, let me divide this properly. We can say that summation r equal to 1 up to n 6 r squared plus 6r minus 5 over, okay, sorry, let me write this properly. 6r squared so 6r squared over r squared plus 1 plus r, so is the same as, now, summation from r to 1 to n, summation 6 minus 5 over r plus 1, which is the same thing as summation r equal to 1 up to n 6 minus summation r equal to 1 up to n 5 over r plus r into r plus can be broken down to a over r minus b over r plus 1, and our a is 5. That will be 5 over r. 5 over r What's our b? Our b is minus 5. Minus 5 over r plus 1. So when you open the bracket by minus, then we have summation r equal to 1 up to n 6 minus open the bracket by minus 5 over r plus 5 over r plus 1. So which I can also write as summation r equal to 1 up to n 6. Let me bring this one out. Summation r equal to 1 up to n 5 r plus 1 minus 5 over r. I remember that this one, summation r to 1 up to n, will give us 6n. So now 5 is common here. This can be written as plus 5 summation from r to 1 up to n. What do you have here? 1 over r plus 1 minus 1 over r. And so let's use the method of differences to solve it. Remember that there's 6n here already. Leave it. There's 5 here. So this is a 5 outside. Method of differences. Now from n r equal to 1, when r is 1, this one becomes 2, while this one is 1. When r is 2, this is 1 over 3, 1 over 2. When r is 3, this one gives us 1 over 4, this one gives us 1 over 3. You know, we are going to do it up to, let me omit 1, and the last, let me just find the last term, up to n term. The n term is 1 over n plus 1 minus 1 over n. Let's see the trend and conclude on what to do. 1 over 2 minus 1 over 3 is out. 1 over 3 minus 1 over 3 is out. Definitely 1 over 4 and whatever here will be out. And this and whatever is here will be out. So what is left is 5 into bracket minus 1 plus 1 over n plus 1, which is the same thing as minus 5 plus 5 over n plus 1. So n's. Some n's, the answer will give us 6n plus 5 over n plus 1 minus 5. That's the answer in terms of n. I believe it's clear. Now the next question. Now, because we should also find summation from r. I'll start from n plus 1 up to 2n of this. Okay, now one thing about this kind of question is a bit trickish. In my first video, I think I solved something like this. So what we'll do is this, since r is not starting from 1 or 0, we have a logic. The logic is best explained with an example. Now for example, now this is just an example, please pay attention. If you are given to find summation from 17 to 48 of let's say 4r plus 1, what do you do? What you do is this: write out as the difference of two separate sums. One will start from 1 to 16, not up to 17. One will start from 1 to 16. So which means you write from 16, from 1 will start from 1 to 16, and the other will start from 1 to 48. So what you do is that you just write from 1 to 48 of what we are dealing with, minus the order we start from 1 to 16 of what we are dealing with. That's just the best logic. What I'm trying to do is that I write out as the difference of two separate sums, one with limit 1 to 16 and the other with limit 1 to 48. So if you're going to apply that logic to this, so it's going to be, we have summation r equal to n plus 1 up to 2n. Already we've delocalized 6r plus 6r minus 5 over r squared plus 1. We've broken it down into, from the previous question, I think it's into 6n plus 5 over n plus 1 minus 5. It's been broken down first in the previous question. Let me show you. This is the 6n over 5n. It's been broken down already. So the logic is, like I did in this one. I started the limit from, I wrote two separate sums from 1 to 48 first. That'll be from 1 to 2n of what we are dealing with. Minus this r equal to 1 or n r equal to 2n minus another sum from 1 to, the first one is from 1 to 48, 1 to the maximum limit, minus from 1 to a limit less than 17. This will now be from 1 to a limit less than n plus 1. This is from 1 to n. Yeah. The limit we are dealing with 6n plus 5 over n plus 1 minus 5. So therefore, now let's substitute. R equal to 1 is common to both of them. So that's the common limit. You just substitute when n is 6, when n is 2n. That will be 6 into bracket 2n plus 5. N is 2n minus 5 minus 6 when n is n minus when n is n plus 5. I also open the bracket by minus. Minus 5 plus 5 is out. This is 12n minus 6n. We have 6n. So plus 5 over 2n plus 1 minus 5 over n plus 1. The question says should be in terms of n. So it's okay like this. I believe it's clear. Now number 3 question. The equation x is to the power 4 minus x squared plus 2x plus 5. Now this equation has root. The root of this equation. What do we mean of root? Root in an equation means the values of x are the root of an equation. So they told us that the value of x for this equation, the value of x is alpha, beta, gamma, and delta. That's the value of this root. And the question now asks us to find a quartic equation. What's quartic? Quartic is the power of 4. We have to find a quartic equation whose roots are, okay, now I don't know the equation, but the roots are, let me say the root, let me put down as y. If this one is x, let me put down as y. So I'm looking for an equation whose roots are alpha squared, beta squared, gamma squared, and delta squared. And also you have to find this and state the value of S2, alpha squared plus beta squared plus delta squared. So from here, so let's find the quartic equation. Now, since we put the new equation you are looking for, we assume the root to be y, which the question said the root are alpha squared plus beta squared, gamma squared, d squared. And you all know that previously the previous root, x is alpha, beta, gamma, or this. So if x is this, then y will be x squared, because x is alpha, beta, gamma, and delta. Y is alpha squared, beta squared, gamma squared, delta squared. So y will be x squared. So if y is x squared, x will be square root of y. Then substitute x inside this equation to find the root, to find the equation whose root is y. Therefore, we have root y raised to the power 4 minus root y squared plus 2 root y plus 5 equal to 0. Now, root y means y raised to the power half. There's a 4 there. Root cancels square. What do you have? Y plus 2 root y plus 5 equal to 0. Y raised to the power half times 4 will give us y squared minus y plus 2 root y plus 5 equal to 0. Now let's simplify. So in order to evaluate or remove radical is a square root. So separate the equation from, separate the one with radical from the rest. So 2 root y will be, let's say, y minus y squared, y minus y squared minus 5, y minus y squared minus 5. So to take away the radical, square both sides. That will be 2 root y all squared, y minus y squared minus 5 all squared, which means I'm going to repeat this twice. 2 twice squared will give us 4y. So equal, now open a bracket, y times y squared minus y cubed minus 5y. Now the next term, minus y squared minus y cubed plus y raised to the power 4 plus 5y squared. The next term, minus 5y plus 5y squared plus 25. So therefore we have 4y equal, collect it, let's rearrange it. So y raised to the power 4, the first term, this is y cubed makes minus 2y cubed, y squared 6y squared, this is 11y squared plus 11y squared minus 5y minus 5y, that's minus 10y plus 35, which will be y raised to the power 4 minus 2y cubed plus 11y squared. When 4y comes here, it becomes minus 14y plus 25 equal to 0. This is the quartic equation. So this is the equation we're looking for, whose roots are alpha squared, beta squared, and gamma squared. Perfect. Now, the question also asks us to state the value of alpha squared, beta squared, gamma squared. That's the sum of the square. That's what they have to state, the sum of the square. Already the root of this equation, let me change the color please. Already the root of the equation, the root of this equation is alpha squared, beta squared, gamma squared, and delta squared. So we have to find the sum of the root, that's the meaning. What the formula for sum of the root? In this case is square. The sum of the root is always minus b over a. So minus minus 2 over 1. So the sum of the root is 2. I think that's what the answers do. Oh, the space is even enough. So hope I've not missed anything. The quadratic equation and the sum of the root, which is 2. Now, for the next one, I'd find the quadratic equation. Find the quadratic equation. This is the value of this. I've done that. So B, the B part, we have to find 1 over alpha squared plus 1 over beta squared, 1 over gamma squared, and 1 over now. So this means okay. To do this, okay. Now this is inverse of sum of root. As inverse, this means inverse of sum of root is written like this. Inverse of sum of root for quadratic equation, we can get it as sum of that product of the three root we are talking about, product of the three root over sum of all the roots, sum of all the roots. Now, okay, let me go back to the quadratic equation. Remember, the quadratic equation is y raised to the power 4 minus 2y cubed plus 11y squared minus 10y, minus 14y, I guess, plus 25 equal to 0. Now, like I said, the roots are alpha squared, beta squared, gamma squared, delta squared. So the sum of the roots is minus b over a, as we did earlier. Sum of the roots. Sum of product of two roots, that's c over a, usual. That will be that's c over a, and c is 11 over 1. That's 11. Sum of product of three roots will be minus d over a. That's minus 14 over 1. The answer is 14. And sum of the product of the four roots at the same time, that's e over a. In this case, that's 25. Product of all the roots at the same time. So sum of the inverse of all the roots, like I said, is sum of the product of three roots. And three roots in this case is 14 over sum of all the four roots at the same time, which is 25. So the answer is 14 over 25. The last one, number 2, we have to find the sum of 4 roots, or the alpha is power 4 plus beta is power 4 plus gamma is power 4 plus delta is power 4, which is the same thing as this. I delocalize it into the root given in the question. Now the roots are in terms of square. So now remember that which means this is equivalent to sum of the roots. Now, so what we do from here, this is just like this, it's just like this. It's also the same thing as S2. The root of the equation raised to power 2 is called S2. The root of the equation are in form of alpha squared. That's the root. It now has the power of 2. That's S2. And remember that our S2 formula is summation of the root all square minus 2 summation of product of the roots you're talking about. So S2 will now be summation of the root is 2. We got it before, all square. Product of two roots, we got it here. I did it earlier. Product of two roots, that's 11. This 11. So S2 will be 4 minus 2 squared is 4. 2 times 11, that's 22. 4 minus 22 is minus 18. That'll be the answer. Got it? Yeah. Now question 4. Question 4 is a matrix question. Now the matrix M is given by cos theta minus sine 2 cos 2 theta minus sine 2 theta sine 2 theta cos 2 theta. Theta is between 0 and pi, and k is a non-zero constant. So the matrix M represents a sequence of two geometrical transformations, one of which is shear. Okay, we have two geometrical transformations. One is a shear. You see it. Now this one here, the second one is a shear. This look like rotation, the first one. Rotation anti-clockwise. Check my last video. I put the formula there. The questioner asks us to describe fully the order transformation. Okay, and state the order. This is very important. The order in which transformations are applied. Now, obviously, they said state the order transformation, the other one, and state now. So this is it. The order transformation, the second one here. So shear. Let me write it like this. Shear is the second matrix. Shear is the second matrix. Of course, this year they've already written it. I think they told us shear the second matrix. So the order transformation ends. The order transformation. The order, they mentioned shear before. So the order transformation is good anti-clockwise. Let me put like that. Anti-clockwise rotation. The other is anti-clockwise rotation about the origin. Through an angle 2 theta. Hence, order of transformation. Now the one written second, when you are mentioning, is the one we usually mention first. Order of transformation is shear in x direction. Shear in x direction, followed by rotation. In an anti-clockwise direction about the origin. 2 angle 2 theta. That is what they asked us to do. Now B, write inverse of M as product of two matrices. Now, product of two matrices. If M is matrix C multiplied by matrix D, the inverse of M can be written as CD raised to the power minus 1. So how do you write it? It's written as the second first D inverse multiplied by C inverse. That's what the question is all about. So inverse of M will be, the product of two matrices. The first one is anti-clockwise rotation. Second one is shear. This D is shear. C is the rotation. When I'm doing the inverse, I did shear first. So and shear is 1 0 K1 raised to the power minus 1. That's the inverse. Cos 2 theta sine 2 theta minus sine 2 theta and what? Cos 2 theta inverse. Let's find the inverse. Inverse of 2 by 2 matrix is 1 over the determinant of the matrix. At the end of the day, we swap A and B. The B, we put negative, negative. That one is not swapped. I believe you understand what I'm trying to do. So now let's find it. So the inverse will be, now what's the determinant of this matrix of shear? 1 times 1, 1 minus 0 times k is 0, 1 minus 0 is 0. So the determinant is 1. 1 over 1 is 1. Like I said, you swapped 1, 1. The other one, you just put negative. Negative of 0 is still 0. This is the inverse of the shear. Let's do the inverse of rotation. For rotation, let's find the determinant. That will be cos squared 2 theta minus sine squared 2 theta. So we have cos squared 2 theta plus sine squared 2 theta. Cos squared 2 theta plus sine squared 2 theta give us 1. So the determinant is 1. So according to the formula, 1 over 1 will give us 1. So you now swap this cos 2 theta cos 2 theta, you swap it. You now put negative in the existing one. This one will now turn to positive. Sine 2 theta, put negative here, minus sine 2 theta. This is the inverse of the inverse as product of two matrices. That's the answer. I believe it's clear. Okay, okay, the next one. Now the next one is in terms of k. How many pages? In terms of k. Okay, that's fair. In terms of k, find the value of tan theta for which m minus I is a singular matrix. For which n minus I is a singular matrix. Okay. For singular matrix, the determinant of m minus I will be equal to 0. Now, what is m? M, from the first question, that's cos 2 theta sine 2 theta minus sine 2 theta cos 2 theta multiplied by 1 0 k1. That's m. Check the first question. This is it. You can see that's m. Look at m here. Minus I. I is an identity matrix. So the matrix is 2 by 2. So 1 0 0 1. So let's evaluate this before we find a determinant. First, let's deal with the product of two matrices first. First row, first column. That will be first row, first column. That will be cos 2 theta times 1 cos 2 theta minus sine 2 theta times 0. That's 0 out. Cos 2 theta times k. That's k cos 2 theta minus sine 2 theta times 1. That's minus sine 2 theta. Let's move to the second matrix. Sine 2 theta times 1. That's sine 2 theta. Cos 2 theta times 0. That's 0. Sine 2 theta times k. That's k sine 2 theta plus cos 2 theta. We are done with the product. This is the product of the matrix. Subtract it from the identity matrix 1 0 0 1. When you subtract it, what will it give us? This one will give us cos 2 theta cos 2 theta minus 1. The other one will give this minus 0 will give us k cos 2 theta minus sine 2 theta. Sine 2 theta minus 0, that's sine 2 theta. This minus 1, that will be k. That will be k sine 2 theta plus cos 2 theta minus 1. Now, this is m minus I. Now let's find the determinant of m minus I. Multiply this by this, subtract it by multiplication of this and this. Let's do that. That will be cos 2 theta minus, I think it's minus 1. I think this is 1, right? Cos 2 theta minus 1 multiplied by k sine 2 theta plus cos 2 theta minus 1 minus sine 2 theta bracket k cos 2 theta minus sine 2 theta. Remember that this is the determinant. For singular matrix, the determinant will be equal to 0. So from here, let's open the bracket. Cos 2 theta times k sine 2 theta. That will be k sine 2 theta cos 2 theta. The next one, cos 2 theta times cos 2 theta. That's cos squared 2 theta. Cos 2 theta times minus 1 minus cos 2 theta. Minus 1 times k sine 2 theta minus k sine 2 theta. I'm using minus 1 now. Minus cos 2 theta plus 1. And let me open the bracket by this one now. This one will give us minus k cos 2 theta sine 2 theta. This time is plus sine squared 2 theta. Remember, it's equal to 0. So from here, k sine 2 theta cos 2 theta, k cos theta are the same. They cancel out. Now, cos squared 2 theta plus sine squared 2 theta obviously will give us 1. This is minus cos 2 theta minus cos 2 theta. That's minus 2 cos 2 theta. This one is minus k sine 2 theta plus 1 equal to 0. Okay, you have to look for tan theta. So from here, 1 plus 1 is 2. 1 plus 1 is 2. So we have 2 minus 2 cos 2 theta. Let me put like this, equal to k sine 2 theta. Now 2 is common, bring it out. Or let's do like this, minus 2. What's cos 2 theta from your P3 maths? Cos 2 theta is okay, let's do this. It's cos squared theta minus sine squared theta. And cos 2 theta can also be 2 cos squared theta minus 1. Cos 2 theta can be 2 cos squared theta cos squared 2 theta. No, 2 cos squared theta minus 1 cos 2 theta, sorry. Cos 2 theta is 2 cos squared theta minus 1. Sine 2 theta can be 2 sine theta cos theta. So here we 2 minus 4 cos squared theta minus 2 equal to 2k sine theta cos theta. 2 minus 2 is out. Here we have 4 cos squared theta, that's cos theta equal to 2k sine theta cos theta. Cos theta cancel cos theta. So what we have here is divide 2 by 2. That will be minus 2 cos theta equal to k sine theta. So divide both sides by cos theta. When you divide both sides by cos theta, what do you have here? Minus 2 equal to k tan theta. K tan theta. So from here we have okay, there is a little mistake in minus. Hold on. It's from here. When you're expanding minus, you need to be very careful when you expand your minus. It can okay, from here. Now here we have 2 minus 4 cos squared theta plus 2, minus and minus, so equal to here we have 2k sine theta cos theta. 2 plus 2 is 4. We have 4 minus 4 cos squared theta equal to 2k sine theta cos theta. 4 is common. We have 1 minus cos squared theta equal to 2k sine theta cos theta. 1 minus cos squared theta is sine squared theta. 1 minus cos squared theta is sine squared theta, which is this. This 2k sine theta cos theta. Sine theta cancel sine theta. 2 here 1, 2 here is 2. What left is 2 sine theta here equal to k cos theta. So divide both sides by cos theta. Divide both sides by cos theta. Cos theta cancel cos theta. So we have 2 tan theta equal to k. So what is tan theta? Tan theta is k over 2. That is what the question asks us to look for. Find the value of tan theta, k over 2. Now the question. Now given that 2 is 3, k is 2 3, and theta is 1 over 3 pi, show that the invariant point of transformation represented by m lies on 3y plus 3x. Okay, you can still remember that our m is cos 2 theta, now to be theta is pi over 3, and minus sine 2 theta. I'm replacing theta by pi over 3, sine 2 theta. Remember, I'm replacing theta by pi over 3, and cos 2 theta, cos 2 pi over 3. These are m. M is this, and 10 k1, 10, and k has been given as 2 root 3. That's our k, 2, 3, and 1. So the question asks us to find the invariant line. Okay, fine. So m will be, let's check the space available for us, very short space. What is cos 2 pi over 3? You count is minus half. This one gives us 3 over 2. This one is minus 3 root 3 over 2. While this one is 5 over 2. So after this after multiplication. So okay, this is when you multiply this by this, and this by this, this by this, and this by this. This is what we have. These are final m. There's no space to show that, but use a matrix to multiply these two together. You're going to have this. Now for invariant line, then now multiply by xy equal to bx big Y. So now let's do the multiplication also. So minus half times x is minus half x, plus the other one minus 3 root 3 over 2y equal to x, equation 1. When you multiply the other one too, that's root 3 over 2x plus 5 over 2y equal to y, equation 2. Now we are asked to show this. Okay, from equation 1, let's see what we have from equation 1. From equation 1, we should take the LCM. We can have, I think, minus x minus 3 root 3y equal to 2x, which is the same thing as 3x plus 3x. This is, which is the same thing as which is the same thing as 3x. Sorry, 3x equal, that will be plus, yeah, 3 root 3y equal to 0. Let's see, is it the same thing as the proof? No, this is 3x, this is 3y. Let's check equation 2. From equation 2, we have root 3x plus 5y, we take LCM, equal to 2y. When you collect the like term, root 3x equal to minus 3y, which is the same thing as root 3x plus 3y equal to 0. Let's see whether it's what happens to 3y plus root 3x. Let's check it, 3y plus root 3x. So this is what they're asked us to prove. That's it. Three y plus root 3x. Let's move to the next question. Done with that. Now number 5. That's polar coordinates. The polar coordinate question. So the question is, Let me check number 6. Okay, vector. Sorry. Now, show that the curve with Cartesian equation. Show that the curve with Cartesian equation x squared minus y squared equal to a, where a is positive constant. A is positive constant as polar equation. This you have to show that this is this. For polar coordinate, x is always equal to r cos theta, y equal r sin theta. So let's make use of this substitution. So x squared will definitely be r squared cos squared theta. Y squared will definitely be r squared sin squared theta equal to a. R squared is common for the r. Cos squared theta minus sin squared theta is equal to a. So r squared cos squared theta minus sin squared theta, of course that's cos 2 theta equal to a. So r squared equal to a over cos 2 theta. So from here, r squared will be a times 1 over cos is sec. 1 over cos theta is what? Sec 2 theta. So r squared is a sec 2 theta. That's what we are asked to prove. Now the next one is the curve C as a polar coordinate. R squared equal to a sec 2 theta, where a is a positive constant and theta is between 0 and less than 1 over 4 pi. It will be very small angle. 1 over 4 pi is 45. Okay, the smallest could be pi over 12 then. Okay, so theta can start from 0. The next one, when theta is 0, okay, let me do this. Let's do like this. Theta can start from 0, pi over 12. Once they are increasing by pi over 12, the next one will be pi over 6. Increasing by pi over 12, the next one will be pi over 4, but it will not reach pi over 4 according to this domain. It's less than pi over 4. So when theta is 0, what's the radius? Let's work it out. R squared equal to a sec 2 0. R squared will be a, because sec 0 is 1. So R will be with a. This one will be with a. So when is pi over 12, that will be a sec 2 times pi over 12, pi over 6. So R will be square root of a and square root of sec pi over 6. So which gives us, the answer will be in 10 to the square root of a sec pi over 6. Use a calculator. Give us 1.15. 1.15. Don't forget the a beside it. Okay, getting it. The next one is pi over 6. When you substitute pi over 6 in it, you're going to substitute pi over 6 and use a calculator in substitute pi over 6. I think it gave us, this one gave us 2a. Is it 2a? No, not 2a. When you find the square root, it's going to give us 1.14 a. So pi over 4, I think we he was infinity because it's not even touching it before. This is the table. This is the table. Now let's sketch the graph. Let's sketch the graph. Now let's sketch the graph. We have something like this. Theta start from 0. The highest is 45. The middle of 90 and 0. So followed by 30. If 30 is here, that's pi over 6. The other one in the middle, pi over 12. So it's there. So this is it. Now you can see that the radius 1.15 is 1.1 is increasing. So let's say at 0 is with A. If with A is here, you know it's positive. If A is here, it will increase for pi. Down increases. For 30, down to increases. You know, so the way it's going, it will not touch pi over 4. If you use your compass to do it well, we are going to have something like this. So the graph is like this. The graph is something like this. Oh. So it's 5 over 12, 5 over 6, 5 over 4, 5 over 12, 5 over 6, 5 over 4. It won't touch this pi over 4 because it's infinite. That's how it will go. So on the question asked, said sketch the graph. This is the sketch. So this is a graph of r squared equal a sec 2 theta. The concept state the minimum distance from the pole. The minimum distance from the pole is when theta is 0. Minimum distance from the pole is when theta is 0. R squared equal to sec a sec 2 when theta is 0. R squared equal a cos 0. This is a. R equal to square root of a. So the minimum distance R equal to a is the minimum distance from the pole. Now the next question. Define in terms of a the exact value of area of the integration enclosed by C. Enclosed by C, the initial line, which is theta equal to 0, and half line pi over 12. From 0 to this, we are looking for the area between. We are looking for the area between initial line, this place and this place at the area again. So what is the formula for area? Of course, you all know that area is equal to half integral r squared the theta, and the concept from initial line theta is 0 to pi over 12, so which will be half integral r squared is what, a sec 2 theta, the theta, don't forget 0 to what, pi over 12. So now when you check your MF9, the integral, okay, this is sec 2 theta. Okay, let's continue first. So from here, this integral can also be, you bring the constant a out, that's a over 2 integral 0 to pi over 12 sec 2 theta. Now let's simplify this. The reason I'm going to simplify this because from the MF9 they gave us that the integral of sec x dx, the integral is ln absolute value of tan half x plus pi over 4 absolute tan half x plus pi over 4 is a constant to integrate sec x, but they didn't tell me the integral of sec 2x is sec x, so I need to simplify this. How do I simplify? I have sec 2x, so put u to be 2 theta. So the u, the theta, when you differentiate u, that's 2. When you cross multiply, the u is 2 the theta. So make the theta the subject of the formula, that's the u over 2. You know, once you start substituting value of u, it will affect the limit also. Now, since u is 2 theta, let's change the limit. When theta is pi over 12, so the new u will be 2 pi over 12, which is pi over 6. This is when theta is pi over 12. U is that. And also, when theta is 0, when theta is 0, u will be 0. So our new limit will be a over 2 integral is now all about u. Pi over 12 has turned to pi over 6. 0 is still 0. Sec 2 theta is sec u, and the theta is the u over 2. This can also be simplified as a over 4 integral pi over 6 0 sec u du. Now it's making sense. Now we can now integrate sec u. Now so a over 4. So when you integrate sec u according to the constant, that will be ln absolute tan half x, that's half u, plus pi over 4. That's it. Don't forget our limit, pi over 6 and 0. Let's substitute. So now a over 4 is outside. Ln. Now when u is pi over 6, I'm going to have tan pi over 6. That's ln tan, that will become pi over 12 plus pi over 4. Now you do it again. instead of putting the absolute again, minus when is 0, that will be lane tan half u. Tan half u is 0 plus pi over 4. Substitute the limit already. So from here, it becomes a over 4 lane. What is tan pi? What is oh, it should be like this. The constant is like this. Okay, let me rewrite the constant here. It's like this. Tan, yeah, all into bracket of tan. That's it. They're all into bracket of tan. I need to clean this. So is lane tan half u is 0. What remains to be pi over 4. Okay. So the constant is like this. Tan into bracket of that. Let me check it from your MF19. It says that a over 4 lane lane tan pi over 12 plus pi over 4 will give us pi over 3 minus lane tan pi over 4. So from here, well, what is tan pi over 3? And that should be, here is a over 4 at the back. Tan 60, that's root 3. Tan pi over 4, that's 1. This is lane 1. Lane 1 is obviously 0. When you open the bracket, that's a over 4 lane root 3. 3 is per half. Move it to the back, that's half times a over 4 lane 3. So the answer is 1 over 8a lane 3. That's the answer. I was able to manage the space. Now let me write NB. Let me write it there. The integral of sec x, the x according to your MF9, is lane tan into bracket half x plus pi over 4. That's it. That's the integral plus arbitrary constant. Number 6, the vector question. Now, number 6, 3 points A, B, and C have position vector I plus j minus I plus 2j plus 4k and minus 2i plus j plus 3k respectively relative to the origin. Find the equation of the plane ABC. Give the answer in the form of plane. So this is A, this is B, this is C, relative to the origin. You are given 3 points and you have to find the equation of the plane. In this case, the equation of the plane, when 3 forms are given, probably will be OA plus maybe lambda AB plus mu AC. You can pass through OA or OB or OC, but let's use OA. Depends. So let's find AB. So in this context, we need to find these two directions first, AB and AC. So what's AB? AB is OB minus minus OA, which is AB minus OB minus OA. OB is minus 1, 2, 4. OA is 1, 1, 0. So minus 1 minus 1, that's minus 2. 2 minus 1, that's 1. 4 minus 0, that's 4. This is AB. We also need to find the other direction, AC. So what's AC? AC is so let's find AC2. AC is OC minus OA. This is OC minus 2, 1, 3. So we have our AB to be minus 1, minus 2, 1, 4. So AC, OC minus 2, minus 2, minus 1. That'll be minus 3. 1, that's 1 minus 1. That should give us 0. 3 minus 0, that's 3. This is AC. So this is the first direction. This is the second direction. With these two directions, we can get the normal. How am I looking for the normal? Because you have to find the equation of the plane. The formula is R dot n equal to A dot n. R is the position, x, y, z. N is the normal. And from this parameter, you can obtain the normal by cross product of the given two directions that you choose. So the normal, the cross product is determinant, plus minus plus I, j, k. So the first direction minus 2, 1, 4. The second direction minus 3, 0, 3. Now take so plus I. So we're going to have 1, 0, 4, 3. We take minus j. We're going to have minus 2, minus 3, 4, 3. Take plus k. We're going to have minus 2, minus 3, 1, 0. So let's find, let's use determinant. 3 times 1 is 3. So 3 minus this one, 3 times 1 minus 0 times 4, that will give us 3. This one will give us 3i. 3 times 2, 6 minus 12. That's kind of 18. Let's be sure of what we're doing. This 3 times minus 2, minus 6. Minus 6 plus 12, that's 6. This one will give us minus 6j. Give us minus 6j. And the last one, 3. 0 times minus 2, 0. 0 minus, that's 3. And give us 3k. So the normal in this context, after multiplying the direction, is 3i minus 6j plus 3k. Now let's find the equation of the plane using R dot n equal to A dot n. R is the position on the plane x, y, z. The normal is 3 minus 6, 3. A, where the equation passes through. OA. Let's choose A. You can choose B. Anyone you choose to do. And in this case, A was A 1, 1, 0. A is 1, 1, 0. And normal is 3 minus 6, 3. At the end of the day, we have 3x minus 6y plus 3z equal to 3 minus 6 plus 0. 3 minus 6 plus 0 is minus 3. So we have 3x minus 6y plus 3z equal to minus 3. Divide 2 by 3. What do you have? X minus 2y plus z equal minus 1. This equation of the plane ABC. Now the second one, find the perpendicular distance from 0 to ABC. Okay, perpendicular distance from 0. From 0 means from the origin. From the origin. 0, 0, 0. From the origin to ABC. And ABC plane is x minus 2y plus z equal to y equal to minus 1. So perpendicular distance, I think we solved this question in paper 1 variance 1, my previous video. Perpendicular distance from a point to a plane. I think we need to use PQ dot n over modulus of n. That's perpendicular distance from a point to a. So P is the one from the origin. Q is any point on the plane. Let's pick any point on the plane. So when if x, let's assume x to be 0 on the plane. If x is 0 on the plane, then we're going to have, as in, you pick any point on the plane. Oh, let's do it like this. To pick any point on the plane, just pick any point. If you pick one point, the other variable will be equal to 0. Let's pick x. So y and z will be 0. If y is 0, z is 0, x is minus 1. The other point at 0, that will be q. So what's pq? So pq is oq. oq is minus 1, 0, 0, minus op, origin, 0, 0. So pq will give us minus 1, 0, 0. I know the normal is 1 minus 2, 1. That will be the normal of this plane. So let's put this in the formula. So let's put this in the formula. I remember that, okay, so it will be modulus. What's PQ? PQ is minus 1, 0, 0, dot the normal. Normal is 1 minus 2, 1. All over modulus of the normal. That's square root of 1 square plus minus 2 square plus 1 square. So therefore, minus 1 times 1 minus 1 give us, it's still modulo minus 1 plus 0 plus 0 all over 1 plus 4, that's 5. 5 plus 1, 6 over square root of 6. Remember, this absolutum is to take away negative. At the end of the day, what do you have? 1 over 6. So 1 over 6 is 0.408. So this is the perpendicular distance from O to plane ABC. Question C, which is the last part on the vector, 8 marks. This must be really wonderful. Find the vector equation of the common perpendicular to the line OC and AB. Common perpendicular to the line OC and AB. OC and OB. Let's say this is OC. Let me say this is OC. Line OC. This is line OC and AB. We said common perpendicular to the line OC. Okay. This line is perpendicular to both OC and AB. Common perpendicular. So now there's a point on OC. Let me call it M. And there's a point on AB. Let me call it N. Now M is on line OC. Now what's OC? Remember that I got AB before. Let me see. I need OC, right? Let me see whether I have OC. Oh, OC. OC is vector C minus 2, 1, 3. OC is minus 2, 1, 3. That's OC. I got AB before. I think AB is minus 2, 1, 4. Minus 2, 1, 4. That's OB minus AB. AB, yeah, minus 2, 1, 4. That's our AB. Like I said, OC, point M is on line OC. So let's find the equation of OC. I want to find the equation of line OC. Leave this page, just one pages, man. Let me find the equation of line OC. For line OC, the equation of line will be R equal to, it's coming from O, origin, in the direction of OC. It's coming from O in the direction of OC. So equation of that line will be O is the origin, 0, 0, 0. OC is minus 2, 1, 3. Since point M is on OC, so point M is going to take the equation of OC. So point M is lambda minus 2, 1, 3. Equation 1. The same thing with point N. Point N is on AB. The equation of AB is coming from A, O plus, let me use TAB. So sorry for my, so OA, what's our OA? That's vector A. OA is is it 0, 0, 1, 1, 0. OA. That's vector A. 1, 1, 0 plus direct TAB. AB is minus 2, 1, 4. At the end of the day, since N is on AB, N will take the equation of AB. It's now become 1 minus 2t, 1 plus t, and 0 plus 4t. This is ON. Now, from what you can see, you'll notice that MN, the space is quite small. Let me be changing color to make it unique. You notice that MN is perpendicular. So this, let me separate this so not mix it. So this is it. Okay, let's manage the space properly. From the screen, you see that MN is perpendicular to OC, and MN is also perpendicular to AB. We're going to treat this information separately. Since MN is perpendicular to OC, MN dot OC will give us 0. Now what is MN? That's ON minus OM. Dot OC will give us 0. So let's find Mn. On, what's On? On is 1 minus 2t, 1 plus t, and 4t, minus On. What's On? Minus 2 lambda, lambda and 3 lambda. When you subtract them, so this is Mn. So Mn will give us what? That will be 1 minus 2t plus 2 lambda, 1 plus t minus lambda, and 4t minus 3 lambda. This is our Mn. Remember that this Mn is perpendicular to OC and also perpendicular to AB. You're going to apply the rules when two vectors are perpendicular to each other. The scalar product of such vector will be equal to 0. So now, let me do Mn to OC and Mn to AB. So Mn to OC, Mn to OC will be 1 minus 2t plus 2 lambda, 1 plus t minus lambda, 4t minus 3 lambda, dot OC. What's our vector C? OC minus 2, 1, 3. Minus 2, 1, 3. They must equal 0. So this is one part. I'm done with Mn, that part. So from here, this is going to give us minus 2 plus 4t minus 4 lambda. This is a scalar product, plus 1 plus t minus lambda plus 12t minus 9 lambda equal to 0. So from here, 4t plus t, that's 5t, 5t plus 12t, that's 17t. What again? Minus 4 for lambda, that's minus 5. Minus 5 minus 9, that's minus 14 lambda. Minus 2 plus 1 is minus 1. Do you have another number there? That's minus 1. Then it will be equal to 1. This will give us equation 1 from the. Now, from the second condition, you also know that Mn is also perpendicular to AB. I'm going to do the same thing. Rules. Mn is 1 minus 2t plus 2 lambda, 1 plus t minus lambda, 4t minus 3 lambda, dot AB. What's our AB? Our AB minus 214 minus 214, that's our AB. The scalar product of this must give us 0. Let's confirm our AB minus 214. Let's do that again. This will give us minus 2 plus 4t minus 4 lambda plus 1 plus t minus lambda plus 16t minus 12 lambda equal to 0. So let's do the needful. 4t plus t, 5t, 5t plus 16t, that gives 21t. The next one, minus 4 minus 1 minus 5, minus 5 minus 12 minus 17 lambda. The numbers now, minus 2 plus 1, I think it's minus 1, is going to give us 1. So this will give us equation 2. Now let's solve the first and the second equation simultaneously. The first equation is 17t minus 14 lambda equal to 1. Second equation is 21t minus 17 lambda equal to 1. Let's use the elimination method. This multiplied by 21 and this multiplied by 17. So let's do that now. So 21 times 17, what do we have? 21 times 17, we have 357. So this is 357t. 21 times 14, so you have 294. That's 294 lambda equal to 21. The same thing here, 357t minus 4. 17 times 17, we have 289. Here is 289 lambda equal to 17 times 1 is 17. Elimination method, this is out. Minus 294 plus 289. That gives us minus 5. This part gives us minus 5 lambda. 21 minus 17. That gives us 4. So 5 lambda. So here our lambda is minus 4 over 5. So to get t, let's substitute using either equation 1 or equation 2. 21, you get the same answer. Now from equation 1, I have 17t minus 14 lambda equal to 1. My lambda is minus 4 over 5 equal to 1. So let's do our evaluation. If you do evaluation, t will be minus 3 over 5. That's our t. And they ask us to find the common perpendicular. So to find the common perpendicular, okay, can be ON in the direction of MN. So let's find the exact value of MN. So MN here will be 1 minus 2t. T is minus 3 over 5 plus 2 lambda minus 4 over 5. 1 plus t, so it becomes 4 over 5. 4 minus 3 minus 4 over 5. So evaluate your MN. So MN will be, so your MN will now be 1 minus this plus this. The first term will give you 3 over 5. The second one, 1 minus 3 over 5 plus 4 over 5. That's 5 minus 3, 2. 2 plus 4, 6 over 5. And the third one, minus 12 plus 4 times minus 3. That's minus 12 plus 12. That is 0 over 5. That's 0. So 3 over 5 is common. So what do you have here? 1, 2, 0. That's your M. This is your MN. But the question asks us to find the common perpendicular. You know, it can be OM or ON in the direction of MN. Now we already have direction of MN. So let's find vector OM. That's common to OC and AB or ON. So OM will be, where is our OM? Vector M. Where is it? OM. Yeah, that's lambda minus 213, and our lambda is 4 over 5, minus 4 over 5, that's our lambda, minus 4 over 5. So OM will be minus 4 over 5 minus 213, that's OM. So the common perpendicular, will now be minus 4 over 5 into bracket minus 213 in the direction of MN. That's this 3 over 5, 1, 2, 0. Or since the scalar, you can put just alphabet. Anyone is correct. That's it. Okay, it remains one more. I would like to do this one in the second video. See you soon.